Okay, guys, how are you? I hope that you all are fine and absolute health and condition. I just welcome you to the channel, which is about industrial and project management related to the aerodynamics and aerospace and aeronautical engineering and the related engineering field that may help us to maintain or build up an aircraft and later on to handle it accordingly to the national and international standards. So first of all, as we are going through some of the thesis and research materials of different research scholars, primarily from IIT, and also we have gone through some of the courses which have actually been taught in different IIT, and that following the same procedure, we have actually selected a thesis or research paper or thesis paper from the website, which is ntrs.nasa.gov/search.jsp, and you can have that research paper from the link. I'm just going to read out an extract just to provide you a solid information about the authenticity that there is, the continuation of the work we are providing, so that you can actually follow on the same route. The purpose here is just to provide you this video with the help of which you can understand the aerodynamics, aerospace and aeronautical engineering. And if you see that if there is any work which is being done similar to this work in any part of the world from any research organization, apart from primarily from USA, or apart from USA, and if you see any other example or any other research work, please share with us so that we can actually provide it to our public. So just for a read, or you can say a transcriptionist approach, but just going beyond the transcriptionist approach to provide the data or the information which can be shared, which can be collaborated when the researchers may put in their comments, or even the professionals or the students who are going through the study want to have some of the quick interaction with the course notes, or even with the thesis written by, or even research at different levels at different research institutes, so that we can help them just get a quick snap or quick check on the study, so that they can handle their course notes, they can handle their study accordingly. That is purpose, to provide an easy to use and easy to follow format as far as the study or even the research work is concerned. That is the primary nature of the videos, especially done on this channel, which is the industrial project management, and which may help to cater the advanced nature of problems normally occur at the research level or at the postdoctorate or doctorate level. So, but normally the students even at the graduate level are keen to study the work at a higher level, obviously to enhance their understanding and capabilities well before time. So for those students who are willing to work prior to the allotted time of their study in their actual time, obviously we can help them to actually just get closer to the point which they can actually help them understand prior to their actual course of study or actual textbook or classes commencement. For this video, the article or research paper is a new formulation of the filter error method for aerodynamic parameter estimation in turbulence. It has been written by Jared A. Groer and Eugene A. Morelli. They are both the research engineer and dynamics control batch at NASA Langley Research Center, which is at Hampton, Virginia 23681. The approach uses an estimate of the measurement noise covariance to identify the model parameters, their uncertainties, and the process noise noise covariance in a relaxation method analogous to the output error method. The method was demonstrated in simulation using the NASA generic transport model, then applied to subscale T2 jet engine transport aircraft in flight modeling results in different levels of turbulence were compared with results from time domain output error and frequency domain equation error methods to demonstrate the effectiveness of the approach. This is the prior introduction how this actually article been gone through, just to get rid of the errors we normally face. The problem description, this section establishes the mathematical framework for the estimation problem considered, and the aircraft flight dynamics are postulated as the non-linear dynamic system. Here are the equations: x by t, x, y, and z according to the time are represented in 1 and 2 and 3. This is, you can go through, where x is the state, u is the control input, y is the model output, z is the measurement, and theta is vector of unknown constant model parameters. And vector functions f and h are known vectors. W and v represent additive process noise and measurement noise, which are assumed to be mutually uncorrelated. Zero mean Gaussian wide processes with spectral density and covariance q and r respectively, which are defined as such, which is in front of you. Equation 1 and 2 are in continuous type, and equation 3 is in discrete type, resulting in a continuous discrete formulation of the system, which accurately reflects mating the aircraft outputs using a digital computer. The system is stochastic because the noise processes are random. Therefore, the initial state is specified by its mean and covariance. This is how you're going to say it. For which a state estimator is used to predict the resulting state and output history, as aircraft dynamics are routinely simplified to linearize equations. A Kalman filter is often used for state estimation. Parameter estimation involves determining the values of theta, such as the model output from equation 1 and 2 best matches the requirements in equation 3. This can be done by maximizing the likelihood function, which is in front of you. This is the likelihood function, where the innovation vi is equal to zi minus yi is the difference between the measured and model output, and where b is the innovation covariance matrix. It is more convenient to minimize the negative logarithm of the likelihood function instead of maximizing the likelihood function directly, resulting in optimization cost function that is in front of you. So the optimal model parameters minimize this cost function, which effectively minimizes the weighted sound squares and covariance of the innovations given the model structure and the measured data. And this is the information which is the parameter estimation methods. You can have the dual state, and normally you can go through, if you just follow the link, you can have the whole article or the research paper in front of you with the different subsections like dual state, parameter estimation, output error and equation error, filter error, proposed formulation, practical aspects and implementation, results, test aircraft and simulation methods, simulation results in light to moderate turbulence, flight test results in flight to moderate turbulence, flight test results in severe turbulence, and acknowledgement and references are also given, and also been actually in the this is the American Institute of Aeronautics and Astronautics. This is the main actually research work in this from this institute, and normally we are also following the IIT Institute, the American Institutes, collectively just to enhance our capability and research. So I believe that with the help of the extract from the research paper I have actually transcribed it in front of you, you'll able to actually get some of the essence which is being transferred through this research paper. And I hope that we're going to follow some of the other channel which is about nautical engineering and also with aerospace engineering. Both deal with the concepts, problems and solutions, dealing from the graduate level to the doctorate level. We are dealing with different problems. Even with the mathematical engineering, you can able to understand how the mathematical engineering with the theory and from the physics point of view can be correlated with aerospace and aeronautical engineering channels as well, so that you can see that what is the whole outcome of the efforts made by the videos or made through these videos, so that you can understand the better actually work as far as the aerospace, aeronautical and aircraft maintenance and manufacturing is concerned, from different angles and from different sources, primarily used in USA and in Indian institutes. So with these remarks, I'm going to end up my video and hope to see you with an interesting video, might be some another interesting channel. If you are following, you can ask about the link. We can actually show you the link. You can directly have some other material as well, so we can actually just enhance our ability and enhance our capabilities. So with the remarks of best wishes for the next video, till then, take care, have a nice day.